Good morning, at least Thursday morning for me. It's Thursday the 26th, so those of you that are viewing this week, that's great. Those of you that are viewing this at some other time, then that's great too. We're just glad to have you here. Look in here, I hooked up a 1 to 500 kilohertz probe. You might not be able to read that. Let's turn it around here the right way. 1 to 500 kilohertz, okay, absolute, that's what that little A stands for. And then we're just looking at serial number, part number. Okay, model number, serial number, they're both there. So we're just going to go ahead and push log to verify that's what we have. Okay, today we're just going to do a simple conductivity screen, okay, alloy sorting if you will, and then just a simple crack detection so you can see the both of those again. And then on your labs you'll have a couple questions about them. So we're going to push the main button. Gives us a big screen. We're just going to erase and null. Okay, we're already at 50 and 50, but let's just make sure of that. So we're going to go to display, screen setup, horizontal position, vertical position, 50 and 50. Okay, we're going to go back to main for frequency 1. It's at 100 kilohertz. I just want to run it at like 250, somewhere in the middle. Okay, I want to take both of these gains and put them at the same. Okay, then I want to run them both down, whoops, I want to run them both down to about 50, just for fun here. Alright, so now I'm going to erase, null, and I'm just going to tap the parts. Okay, I got a pretty good looking little conductivity curve there, but it's not in the orientation I want it. I want ferrite because everything we've kind of seen so far says we got that little imaginary line right there through the center. Anything that goes up here is magnetic. Anything that stays down here is non-magnetic. That's at least how I like to run them. So I'm just going to change my angle. Okay, I'm tapping on ferrite here so I have a little bit of a road map. Now this number over here, this angle doesn't make me any difference. Okay, I just want to go to where ferrite is pointed straight up. Okay, that's good. And you see it's actually come up here. The dot's actually winding up clear over here in the corner. That's because it's maxed out and it has nowhere to go. So, stainless steel, copper nickel, magnesium, 7075 T6, 7075 O. But I'm going to bring my gains down just to where they're just on the inside of my screen. About right there. You can see the dot right down there. Okay, so I'm going to erase, null. You notice I'm nulling in air because I'm looking at the impedance change relative to the probe. Okay, so impedance change between air, which is right here, to the impedance change of 7075O when I'm down here. Okay, because that's what we're looking for. We got the coil in there. We're looking at the impedance difference between air and whatever we're looking at here. In this case, it's just a conductivity curve or alloy sorting. So last week I touched the table a couple different places, and we saw these all over the place. Looks like we got a little bit of aluminum right here. Okay. Yep, looks like magnesium. Okay, now whether it's actually magnesium or not doesn't make us any difference, because depending on thickness and stuff like that is going to give us conductivity variations, so those aren't necessarily true numbers. Okay. Trying to get my cord all unwrapped here. There we go. So just to bring it all back, ferrite, stainless steel, copper nickel, magnesium, 7075 or aluminum T6 and aluminum O for now. Okay? So what you see here, when we just go to T6, okay, that means that we have at least passed the first standard depth of penetration, second standard depth of penetration, third standard depth. Because at that point it's telling us that material is infinitely thick, meaning if there was any more material underneath it, it wouldn't matter. There could be a foot or there could be 3,000 inches. Okay, it doesn't make a difference. So we're just looking at that difference to show us infinitely thick. So if we jump over here to this, okay, we just put a crack standard here. That's 7075 T6. Okay, so it doesn't matter the thickness. It's just telling us, yep, 7075 T6. Okay, and you see just a little bitty crack right there. But we want to separate that out. So the next video we're going to just separate that out so we can see the difference between the two. One thing I want to do here is go to like an alloy sorting type scenario where we have 7075, oops, sorry, I just hit you there, 7075 T6 and 7075 O. Back you up a little bit. So I want to go to something like this where I'm going to put my T6 kind of up here somewhere. So I'm going to go to display, screen setup. I'm going to go vertical position about 90. Okay. Horizontal position about 70. Alright. So now I'm going to null on that material. Okay. So I've got a screen going back there, and I've got a screen, I've got two different representations here. So I'm going to separate these dots out is what I'm looking for. So here's my 7075 T6, and I want to have 7075 O separated way out so I can tell the difference between the two. So I'm going to do this. I'm going to go back to my main, frequency 1, I'm at 250 kilohertz, there's nothing wrong with that. I'm going to go gain. I'm going to run these gains up quite a ways, about 60 or so. Okay, then I'm going to re-null just to see what happens. Okay, there we go. We've done a pretty good job so far separating them out just a little bit. But I want to change my angle. Okay, I want this rotated down so I can tell a little bit more about what's going on. There we go. So now it's like the conductivity curve is way out here somewhere. Okay, but I'm just looking at the very end of it. Alright, so that's separated out okay. I'm going to go vertical gain. I'm going to run it up some just for fun, just so we can see some separation here. So I'm going to re-null here on my T6. Okay, I'm going to take my angle, come down just a little bit, re-null. See, now I've separated the two T6 and O. So anything that falls in between here is showing me an increase or decrease in conductivity. In this case, if we were at O going back to T6, that's a decrease in conductivity. So there's the higher conductivity because it's lower on the conductivity curve, and there's the higher conductivity, or sorry, there's the lower conductivity because it's higher on the curve. I think I just said that completely backwards. And here's the higher conductivity because it's lower on the curve. So low conductivity, high conductivity. And if we were looking at this whole conductivity curve from stainless steel all the way down, it would make a big hook like this. And as that hook comes down, this is telling me that it's increasing conductivity. Okay? So if we just went back to regular old screens here, we go display, screen setup, take everything back to 50 and 50. Push null. Okay, ferrite's kind of going off at an angle, so we need to change that angle. Now we're going pretty much back vertical. But I need to bring my gains equal again. Right there. Okay. So I'm going to null. Oh, we're still a little squirted. Let's take it down to something we can use. Okay. Null. Guess maybe if I nulled an error that would help. There we go. Now we're back. So you see, well, if I would have touched it the right way, let's bring our gains down a little more. Okay, ferrite, stainless, copper nickel, magnesium, aluminum, aluminum. So if we start at air and follow this curve out like this, that's telling us increasing conductivity. Okay, so relatively simple. And then we saw before that line that goes right through the middle, non-magnetic, magnetic. All right? Questions over that? Feel free to email me.